Hi, good morning, everyone. I'm Rajesh. Today we're going to have a demo on Snowflake. So before we kickstart a demo on Snowflake, let me introduce myself. I'm Rajesh and I've got around 14 years of experience in the data engineering world, right from analysis, design, development, ETL and reporting using advanced data warehousing technologies. I've got hands-on experience in Informatica, Tableau, and Python and Unix shell scripting, as well as the Snowflake. I'm an ex-Salesforce and worked for Verizon and Bank of America in my career. I've got good knowledge in data warehousing concepts and as well as big data. I've designed a project end-to-end using Snowflake architecture. So let's jump onto the Snowflake demo. So before we kickstart, let's try to understand why Snowflake. So generally, Snowflake is called as a cloud data warehouse. The reason behind it was because of its unique way of storing the data and its unique way of computing. So in Snowflake, it has given lots of utilities readily available for the developers to build the pipelines much faster than using the traditional ETL tools like Informatica, Talent, Data Stage, etc. So, you need to develop lots of mappings and the infrastructure would take care of running the mappings. Whereas Snowflake, it has given readily available utilities, which made the developer's job very easy to implement in an optimistic way within short span of time. And Snowflake has got attention in the market because of its unique performance. It works much faster than the existing data warehouses or databases in the market. It is because of its unique way of storing the data. Snowflake stores the data in a columnar format, whereas the traditional databases stores the data in a row-wise format. Because of its unique way of storing, called as columnar storage, it is able to manage, store, scale up the storage layer independent of the computing layer. So as I said, Snowflake can scale up and scale down independently the storage layer and the compute layer. So that is the reason we were worried about lots of performances in the traditional databases like Oracle, SQL Server. We need to enforce constraints like, and we need to enforce indexes, partition to gain better performance. But when you see the Snowflake point of view, Snowflake does it everything for us. We don't need to put lots of efforts in increasing the performance. Snowflake can do everything by its own to give the better performance. So developers or companies doesn't need to worry about the performance. Okay, and that is the reason it has got revolution in the market. Snowflake will be able to fetch millions of records within minutes. Like if you want around 30 or 40 millions of records, it should be able to fetch less than 3 to 4 minutes. That's the capability that Snowflake has got in the market. Okay. Apart from Snowflake's performance, and as I said, readily available utilities for the developers to build the pipelines much faster, it has got unique features which we'll be discussing in the coming classes. At a glance, let us see time travel feature. The time travel feature is basically, bringing back the table, to the history at a given point of time. We can roll back the data in the table back to the history at a given point of time. And data sharing, it is one of the unique feature. Data cloning, reader's account, out of box security, you know, and all the JDBCs or ODBCs have got connectors established. And the unique ways, since it is a cloud data warehouse, it is called as pay per second billing. How much seconds we are going to use, you're going to charge it only for the seconds that we use. Okay, so let us go to how we have seen the evolution of data engineering. We had on-premise databases to store structured data and semi-structured data in one database. And then, we have data lake coming up in the second generation, which actually stores unstructured format as well. If you see the evolution on-premise database, it was only able to store structured data and somewhat extend to the semi-structured data. And it was having good performance only when the data is small enough. Coming to the next generation, like we got on-premise onboarded to the cloud, and we don't see any new features added at that point of time. And the third revolution is what data lake. On cloud, the data lake has been concept which has been established to store structured, semi-structured, unstructured data, and we can call it as a Hadoop. You know, but it has got some limitations in terms of performance, which can be better than first and second generation, but still it has got a lot of performance issues. Therein, the Snowflake comes in the picture, which made it possible because of its unique way of storing the data and unique way of scaling the computing layer. The reason why I'm telling it is because the Snowflake has divided its database into three layers. It is called as cloud service layer and the compute layer and the storage layer. Each and every layer is independent to itself. Each and every layer can scale up and scale down independently. Let me say like this. We have a storage layer, right, which actually stores the data in the file system. As I said, it is going to be in the Parquet files, and it is going to be in the columnar format. It can scale up and scale down the storage layer independently. In a similar way, it has got computing layer. Computing is one of the powerful engines in the Snowflake. It actually gets the data from the storage layer, right? And gives back the data to the user. So now this computing layer has got some set of nodes called as a cluster. This computing layer can scale up and scale down as per the demand without scaling or scaling up the storage layer. That is the revolution because of which it is able to give the faster performance than the third generation, which was not actually existing earlier. When we wanted to scale up the computing and the storage layer, it never happened because of they're tightly integrated. But in the fourth generation, they have been separated. The storage is separated from the computing cluster. The storage cluster is completely separated from the computing cluster, because of which we are able to gain better performance and faster performance in Snowflake. Okay, let us move on to the architecture of Snowflake. See how beauty does the Snowflake has got. If you see the Snowflake architecture, I'm just trying to refer, we get the data from different source systems, right? So be it OLTP or enterprise applications, third-party applications, you might get the real time streaming data from the logs or from the IoT devices, right? So these can be a number of, uh, data sources, and each of its own kind, right? OLTP, you will be getting data in terms of transactional base, and enterprise data you may get huge volumes of data, and third party can be anything. It can be Salesforce, it can be SAP, or anything. Okay, web logs, as I said, real time data, or completely unstructured data. Okay, so it has got ability to consume data coming from heterogeneous sources, right? And the beauty of it is, the Snowflake is going to give us a unified storage layer, right? Unified storage layer, which I meant was, you can build data science, you can build big data, you can build data warehouse, you can build artificial intelligence by using the same data which has been stored, right? So this is because it is able to achieve, earlier for storing unstructured data, you need to have Hadoop, right? And when you have a system sitting and storing only the structured and semi-structured data sitting in some other database. But when you wanted to build some analytics on both these machines, you need to procure the data from different systems and then place it on the same system. Again, getting back the data from structured and unstructured data, and then put it across to the Hadoop, which maintains this data, right? Here, the Snowflake because of its unique way of storing, one copy of data based on which you can build these many modules, be it data science, be it artificial intelligence, be it data lake, be it big data, be it data warehouse. The single copy of data is being leveraged to build these many modules. Okay. And the most advantage thing is you can configure Snowflake to run on all the three major cloud platforms, AWS, Google Cloud, and Azure. Okay, after we build these kind of modules, be it artificial intelligence, data warehouse, or big data, you can start connecting your reporting entities to the Snowflake. As I said, see, data consumers, you can bypass the data to the third party systems. You can build analytics using Tableau dashboards. Since I said, lot of connectors have already been established to connect to the Snowflake. As I said, we don't need to worry much because Snowflake is capable of fetching millions of records within less seconds. So your Tableau dashboards or Power BI dashboards will work much faster rather than getting the data from a traditional databases and storing the data at an extract level, which is actually not required here. The Power BI reports or Tableau reports, which gets the data from Snowflake, they are going to get much faster, right? So this is basically the architecture of Snowflake. You wanted to see, you can see the Snowflake diagram. I tried to mention it. You can do data mining, you can do data streaming, you can do the artificial intelligence, you can do data science. I tried to mention everything, whatever can be possible on a single copy of data. You can call it as unified environment, wherein you will be able to create lots of modules. Okay, in the coming classes, we shall discuss more on this.